Hi everyone, let's keep learning about the Tidyverse. You guys probably noticed in the title of this video that this is actually the fourth video I do about this topic, okay? Now, in this video, I want to particularly focus on showing you how to use a few functions from the Tidyverse to create two new columns based on the patterns exhibited by the values of an existing column. So how to use one column and the patterns found in the values of that column to create two new columns. All right, let's jump into action. Here we are in our studio, and this is the notebook that I'm going to be using in this video. And in this notebook, I included all the code I used in the previous three videos, okay? And remember, as usual, I will post a link to this notebook in the video description. Also remember that in my videos, I don't want to kind of, waste time typing code. And that's why the code that I'm going to use in this video is already included in this notebook, okay? Perfect. So first, let's start by, because, we want to use the tidyverse, right? So to use the tidyverse, we need to load it. And to load it, we're going to use the library function and the name of the package, which is tidyverse, all right? Okay, so let me execute that code cell. There you go. And now I'm gonna go ahead and scroll down because all of these code cells and explanations, I already covered all of this in the first three videos, okay? So let me just jump to the video for material. Video 3, so I covered all of this already. And here we are in video 4, okay? So let's explore the data frame we are using one more time. So this is the data frame we have been using in these videos, Caravaggio-Kaggle data frame. And let's use the head function to take a look at the first 6 rows from that data frame. Remember that in this data frame, we have data about paintings by Caravaggio, the Italian artist. And, for each painting, we have the year when the painting was painted, the title of the painting, origin city, destination city, and so on and so forth. Um, in video 1, we focused on exploring and cleaning the year column. In video 2, we focused on origin city. Video 3, destination city. And now in this video, we are going to focus on the dimensions column, okay? And our goal would be to split this column into two new columns because actually notice the format followed by the dimensions column. So we have two values, right, for dimensions. So one value, comma, space, and another value, okay? The first value is actually the height of the painting, and the second value is the width. So I think it makes sense to have two individual columns. So one with the height and another one with the width, okay? And actually the columns should be numeric. Notice that right now, the type of dimensions is character, okay? I think it makes more sense to have dimensions as numeric, okay? Um, why? Because, for example, when I used this data set before, I did a plot where I was showing the area of the painting. So to use the area of the paintings, I had to use the dimensions to compute the area. To be able to do that, you need the dimensions to be numeric, okay? So definitely it makes more sense to have the dimensions as numeric, okay? Perfect. All right, so that's what we're gonna do. So we're gonna split this dimensions column into two new ones. All right, that's our task. Split the dimensions column into two numeric columns, one for the height, one for the width. Now, first, let's check if all the values in the dimensions column have the same format. What do I mean by the same format? So by looking at the first 6 rows, we notice a format, right? Possible format. So a value, first number, comma, space, and the second number. And then the same thing here, right? A number, comma, space, and a second number, and so on and so forth, right? But we usually we really need to check, because although it looks like all the values in dimensions follow that format, we should actually explore the column to confirm that they do. because if all the values don't follow that format, we need to take that into account when splitting the column, okay? So let's see. So one way to do that, I guess there are many ways, but we can actually just to that data frame apply the select function part of the dplyr package and select dimensions to only focus on dimensions, okay? And then explore the dimension columns more easily, okay? All right, let's take a look at that. So here, the whole output, it split it in many parts, okay? Well, initially it looks like all the values follow the same format. So let's see the second part of the output. But now notice that there is one value with a different format. Diameter equals 58. And the problem is that that painting is not rectangular, it's circular. So that's why its dimensions are different, okay? And let's keep exploring. And now we see something different as well. So for one painting, the dimensions are given in spans. Spans is an ancient measure of length. Okay. The other dimensions are in centimeters. Okay. So all of these numbers are in centimeters, but there is one that is in spans. Okay. That's something that is different. Okay. So far we notice that yes, most of the values follow the same format, but two paintings have a different format. Okay, and if you keep exploring, you're gonna see also like for one painting we don't have NA, so we don't have the dimensions for one of the paintings, and I think the rest is fine. Okay, so we don't see anything um different or interesting after that. Okay, so three observations. So three observations after checking the dimensions column. The first observation is that all, all right, all but two paintings have their dimensions recorded using a common format. Height in centimeters and width in centimeters, okay? But two paintings don't follow that format. For one painting, the dimensions are given in spans instead of centimeters, okay? And we're gonna be able to take care of that. So we're gonna be able to change the dimensions from spans to centimeters, and you'll see how in a second, okay? But that's something that we're gonna be able to take care of, okay? And finally, the third issue, let's call it issue, is that another painting is not rectangular but circular. Therefore, it only has one dimension, its diameter. And for these guys, as I'm saying here, there is nothing that we can do about this, okay? We just need to be aware that one painting has a different geometric shape, okay? But we cannot do anything about that, okay? So for one painting, the dimension is not height and width, but it's just the diameter, okay? So nothing we need to do about that, all right? Perfect. Let's take care of this first, okay? So before actually splitting dimensions into two columns, let's take care of this issue. Let's call it issue. So let's change that the dimensions for that painting from spans to centimeters, all right? And first, I guess we should know what is the painting, which dimensions are in spans. So we know a painting has its dimensions in spans, okay? This one. But what is that painting? What is the title of the painting? The year when it was painted, right? So let's find out what is the painting with that issue. All right. Well, in that case, I guess one convenient way of retrieving that painting is by using the filter function. Remember, filter is a function from dplyr that allow us to select certain rows. So if you only want to select certain rows, you can use filter, okay? And in this case, we want to select only one row, the row for which the dimensions are in spans, okay? So we can say, okay, from this data frame, apply the filter function. And I guess we can do this in many different ways, but basically what I want to do is give me the rows for which the dimensions has the word spans in it. You know what I mean? So detect the word spans in dimensions and retrieve that painting. Okay, so we can do that easily using the string detect function. And for the string detect function, this is what we want to do. Okay, detect in dimensions the word spans. Okay, so if you detect in the column dimensions the word spans, retrieve that row. Okay, so let's see. And here we have it. Here we can see that that is the painting in question. So it's the Crucifixion of St. Peter, okay, painting in this year. And as we can see, that's the one with the dimensions in expanse, okay? So how are we going to change the dimensions from expanse to centimeters? Well, I went ahead, and that's what I wrote here for you guys. I went ahead and reviewed the source book. Remember that as I told you in the previous videos, I created this data frame from a book about Caravaggio. I went back to that book and and in that book they mentioned that the centimeter dimensions of this painting, okay, of the Crucifixion of St. Peter, coincide with those of this other painting, the conversion of St. Paul, um, um, available at the Descalchi Palace. So that's a word in Italian, so it's kind of hard to pronounce. Or the Descalchi Palace, all right? So in the book, they say, you know what? The centimeters dimension of this painting coincide with this one, conversion of St. Paul at the other Calci Palace, okay? So that's great. So all I have to do now is retrieve the dimensions of this painting, okay? And then use those dimensions to replace the expanse dimension for the crucifixion of St. Peter, okay? All right. So how am I gonna retrieve the dimensions for the conversion of St. Paul at the other Calci Palace? Easy. So we can use this the filter function again, but now we need to filter by two conditions, okay? Not by one, but by two conditions. We can say from this data frame, filter, and this is the filtering condition. The title needs to be equal to conversion of St. Paul, and this is the and logical operation in R, title convention of St. Paul, and the place of destination is all the Calci Palace. All right. So here we're filtering by using two conditions: this condition and this condition. Okay. So the ampersand symbol represents the logical and in R. Okay. And sure enough, after we do that, we can retrieve that painting and we can see the dimensions. Those are the dimensions. So now I'm gonna go ahead and use those dimensions and place them instead of this one. So for the crucifixion of St. Peter, I'm gonna place 237. I'm gonna replace the 10, 10, 10,8 spans by the 237, 189, right? All right, and to that, you know, by watching my previous videos that we should use the mutate function, okay? This is the way we're gonna do it. We're gonna say, you know what? From this data frame, I want to mutate the dimensions column, okay? I want to mutate or change the dimensions column. Do I want to change the whole column, like the values for all the rows in that column? No, actually, I want to change the dimension columns following the logic behind this if-else condition. And this is the logic in the if-else condition. When the dimensions are 10,8 spans, change that to 237, 189, okay? All right, so when this condition is true, if this is true, return this, okay? Return that. Else, so if that condition is not true, any other case, basically, just keep dimensions untouched, okay? So just keep dimensions equals to dimensions, all right? Keep dimension untouched whenever this is not true, okay? And if we execute that, we're gonna be able to only change the dimensions for this painting, all right? And remember that when you're using mutate, if you want to make the output from mutate permanent, you need to assign back the result to the data frame. So that's why here you see that I'm assigning back the result from mutate back to the data frame. Okay, don't forget that. And sure enough, we execute that, and now the spans were changed to centimeters. All right. So I guess we can confirm. We can. So let me just retrieve crucifixion of St. Peter, and just to confirm, okay, just in case you want to confirm. All right. just in case you want to confirm, we can say something like Caravaggio filter where title equals crucifixion of St. Peter's is a string, so we need to enclose that in quotes just to confirm, okay? Just in case you're curious to confirm that the change took place successfully. And this is a quick way. There are actually two crucifixion of St. Peter's, but if we look at the dimensions, now we see that in both cases, the dimensions are in centimeters, but especially this one is 237, 189, okay? Before that one was in spans, all right? So it worked, so the change worked. Perfect. So last change, guys, last change. Let's split dimensions into two new numeric columns. And I want to name those columns like this. Height in centimeters, so that's the first column I'm gonna create, and width in centimeters, okay? Now, guys, to know that, we need to do something with the circular painting, right? Because for the circular painting, the dimensions are just the diameter, right? So we can assign a height and a width value for that painting. So this is what we're gonna do. This is what we need to do. You know, that's what makes sense to do. For this painting, for the circular painting, both height and width will be set to NA. Remember that NA means either missing or not existing. So NA in many cases mean that the data is missing. So the data exists, but it's missing, like we don't know it. But sometimes NA means that the data is not existing. So in this case, NA will mean that it's not existing. It's kind of like like the middle name for some people. So many people don't have middle names. So for many people, when you have data about people in a database or a data set, the middle name is NA, but that NA doesn't mean missing usually. It means not existing, meaning like that person does not have a middle name. Okay, so it's the same thing here. So for that painting, for the circular painting, um, the height and width would be NA. All right. And all right, so let's try to find out how to get the height and the width from the existing dimensions. So let's take a look at dimensions again so that you understand what I'm going to do. So these are the dimensions. Remember, as I said, the first value is the height, the second one is the width. How are we going to get the height? How are we going to get the height? Well, to get the height, we need to tell R using code, because that's the only thing that R understands, code, okay? We need to tell R using code, listen, when you detect the comma, okay, when you detect the comma in dimensions, remove everything from the comma and only keep what is before the comma, you know what I mean? So whenever a comma is detected in dimensions, remove everything from the comma and on. Remove all of that. So if you remove what I just highlighted, what do you keep? You keep the 67, which is the height, right? If you remove the comma and everything that is after the comma, what do you keep? You keep the 70, which is the height, okay? So that's what we need to tell R using code, all right? How can we tell that to R using code? Let's take a look at this. Let's take a look at this, okay? And this is kind of a preliminary step. So because, as I said, I think I mentioned that in my third video, when you're making a kind of a big change, like in this case, we are creating new columns, don't make the change permanent at first. So check that what you want to get is actually what you're getting, and then make the change permanent. So I don't want to make the change permanent yet. I'm just exploring to see, and then if it works, I will make the change permanent, right? So this is the way we're gonna use code to tell R, hey, from the comma and on, remove everything and only keep everything before the comma. All right, so we're gonna say, you know what? For the height, um, let's start. So use mutate, okay? Use mutate to create a new column. Remember that if we use mutate, and you mention a column that does not exist, height centimeters, we don't have a column like that right now, okay? So we saw the columns earlier, right? So we don't have a column right now that is height centimeters, all right? not at all. Okay. So when you use mutate and you mention a new column, that column will be created. Okay. If the column that you're mentioning in mutate exists, well, that column will be modified. But in this case, that column does not exist. So this is what we want to do. This is what we want to do. We want to say, all right, mutate height centimeters, so that will create that new column. And we want to create that new column following the logic behind this if-else condition. What is the logic behind this if-else condition? So when dimensions is not equal to diameter equal 58, so that's our way of saying, you know what, for any painting that is not the circular one, okay? So for any painting that is not the circular one, do this, do that, what I just highlighted. So for any painting that is not the circular, do this. Else, so for the circular, return NA, okay? So that's what we want to do. For any painting that is not the circular, do this, which I'm gonna explain right now what that is. But if it is the circular, just return NA, okay? Else return NA. All right, so for any painting that is not the circular, what do we want to do? All right, so first, we are calling here as numeric because, as I said earlier, we want to convert the 68, like this characters, 67, 70, to numeric, okay? So the final goal is to convert everything to numeric. So we're going to apply a function sub, and we want the result of that function to be converted into numeric. So that's why we're calling as numeric, okay? But what are we doing inside as numeric? So we are applying the sub function. Let me highlight that, okay? We are applying the sub function, okay? What is that sub function doing? Well, the sub function sub is short for substitution. So we want to substitute or replace one pattern by another one. We want to substitute or replace one pattern by another one, okay? And what is the pattern that we want to replace by another one? Well, we want to replace this pattern. We want to replace that pattern by this one, by the empty string, okay? So we want to replace that pattern by the empty string, okay? Now let's try to understand that pattern. And to understand that pattern, you need to remember this. I mentioned this in video 3. Guys, when using string functions like sub, like string detect, some symbols, all right, some symbols, for example, the dot, the asterisk, there are a few symbols, the plus sign, the question mark. So in the context of using some string functions like sub, string detect, some symbols like dot, asterisk, etc., they have a special meaning. Okay, they have a special meaning, and you cannot take them as literal. Okay, literal characters. Okay, so in the context of certain functions, a dot is not a dot. It has a special meaning. In the context of these functions, the asterisk is not an asterisk. It has a special meaning. If you want to use these symbols with a special meaning literally, so if you want to use a dot as a dot, or if you want to use an asterisk as an asterisk, you need to escape them using the /, okay? But that's another story. So we are not gonna talk about escaping in this video, okay? But what I want you to know is that in this context, unless you escape these special symbols, these symbols have a special meaning, okay? And in this case, we see three symbols, a comma, a dot, and an asterisk, right? A comma is not a special symbol. It's not. So the comma is just a comma, literally a comma. But the dot is a special symbol that means any character, even the empty string, any character, even the empty string. And the asterisk means repeated any number of times, okay? So comma, as I said, is just, literally a comma. So comma followed by any character, that's the dot, repeated any number of times, that's the asterisk. When you put all of that together, that pattern means, guys, when you find a comma followed by anything, okay? Comma followed by anything, by any character, even an empty string, okay? All right, so when you find a comma followed by anything, replace that by an empty string. And what happens when you replace a character or a group of characters by an empty string? Think about that. What happens when you replace a character or a group of characters by an empty string? You are effectively removing those characters or that character, okay? So whenever you replace a character or group of characters by an empty string, you are removing those characters, okay? And that's what we want to do. We want to say, whenever you find a comma, from the comma and on, remove all of that, okay? And if you remove all of that, what do you keep? What is before the comma? The 67, which is the height, okay? If you find a comma and you remove everything from the comma and on, what do you keep? You keep the 70, all right? And that's what we want to do, all right? That's what we want to do, all right? And all right, let's check. Let's check if this works. And notice that to check if this works, because like let me show you something. If I don't, let me remove that select. So if I only execute the result of mutate, it's okay, but I'm gonna see all the columns. It's kind of then I need to move to the dimensions and then check. And then, actually that's really inconvenient because when you create a new column, it will be placed in the last position. So it's really, really hard to check if it worked. Okay. It's really hard to check if it worked. Okay. So that's why I said, you know what? After mutate, um, I want to select dimensions. I want to select dimensions and I want to select the new column height centimeters. You know what I mean? Because I can focus on those two columns and check. Okay. And did it work? It looks like it did, right? So here I'm seeing 67, 67, perfect, 70, 70, 66, 66, perfect. So it worked. It worked, okay? And yeah, so it worked. So that's good. That is good. And, for diameter 58, we just got an NA. And for the NA, we get an NA as well, okay? For the original NA, so we still get an NA, all right? Perfect. So that's the way we get the height. That's the way we get the height. How are we going to get the width? How are we going to get the width? All right. To get the width, we want to get, for example, we want to get the 53 only, the 67, the 49.5, right? So we want to get the second number. Well, we can use the same idea, right? We can use the same idea. We need to tell R, hey, whenever you find a comma, okay, from the comma and before, I want to replace that by an empty string, okay? From the comma and before, I want to replace that by an empty string. You know what I mean? So whenever you find a comma, from the comma and before, replace that by an empty string. If you do that, what are you going to get? Take a look at the first example. If you remove 67 and the comma, what do you get? You get a space and 53, right? So in the second case, if you get from the comma and before, uh, what do you end up with? With a space on 67, okay? And that's exactly what we want, all right? That's exactly what we want, what we want. And you may be wondering, but what about the space? The space is okay because, let me show you. Let me remove this. So I opened the console quickly to show you that the space is not a problem. So for example, when you do as numeric, remember that we're using as dot numeric. Let's say if you do as numeric 67, you get 67, okay? But if you do as a dot numeric space 67, you still get 67. You know what I mean? So as numeric kind of ignores the space and only gives you uh, the numeric representation of that character. You know what I mean? So the space is ignored. So that's okay. So if we tell R, hey, give me from the comma and before everything and replace that by an empty string or remove everything from the comma and before, we're gonna end up with a space and the second number, and that's exactly what we need. All right. So how do we tell that? How do we tell that to R? Similar to this, but kind of here we're saying comma and then everything after the comma. Now for the width is the opposite. So everything before the comma, everything before the comma. So let's take a look at the height. I'm sorry, at the width. we're gonna use sub, but we're gonna say, you know what? Any character follow repeated any number of times. Remember the dot. Remember the dot means any character, and the asterisk means any number of times. So any character repeated any number of times, and then a comma. So whenever you see that, so R, whenever you see any character repeated any number of times, and then a comma, please replace that by an empty string, and that effectively remove everything from the comma and before. Okay. So the logic behind the creation of width is the same. The only thing is that we need to replace the pattern. So it's not the comma and after, but before the comma. All right. Is that going to work? Let's see. And it looks like it does, right? 53, 53.0, 67, 67.0. It does work, okay? Now that we know that this works, we can combine, okay? We don't need to use mutate only with one to create one column. We can use mutate to create both columns at the same time. And I'm going to do that now, knowing that this works, okay? We're going to use mutate. Take a look at this. We're going to use mutate to create height, the way I just show you, all right? Comma, what I just highlighted is the code to create height, okay? Comma, and then the code to create width. So again, you can use mutate to create multiple columns at the same time, okay? It doesn't have to be one, okay? That's great. That's a great use of mutate, right? And here I added one more thing. I want the two new columns to be created after dimensions. So we're using the parameter dot after to specify that we want the new columns to go after dimensions. Okay, that makes sense. That makes a lot of sense. I don't want the new columns to be in the last position. That's not a good position. All right. And then just notice that because I want to make the change permanent, I'm assigning the result from mutate back to the data frame. All right. So let's execute this. Let me execute it, and we get a warning just saying like, oh, like NAs were introduced by coercion. That's okay. It's just like we never told R specifically what to do with this NA. Remember that the dimensions were missing for one painting. We let R to figure out what to do by itself. It's just kind of telling us, hey, there was an NA. I didn't know what to do, and it forced the NA to be an A. That's okay. So that worked. Okay. So this is not an error. It's just a warning. All right. And okay, perfect. And let's take a look at the data frame again. And sure enough, guys, you can see that now we have dimensions, and then we have the two new columns, all right, with height and width. All right, guys. So that's all for this video. I just show you in this video how to use the pattern that you detect in the values of one column. How can you use those patterns to create new columns, okay? And in this case, we used mutate, if else, and the function sub to do that, all right? So those were the main functions we used to pull this off. Mutate, if else, and then sub to retrieve specific pattern, string pattern, right? And remember, guys, that in the context of certain functions, certain symbols, not all the symbols, but certain symbols, dot, asterisk, plus sign, they have a special meaning, okay? You cannot take them as literal, right? As literal characters. All right, guys, so that's all for this video. I hope you enjoyed, and I will see you in another video. Bye, guys.